Good morning, I am Leah Riggin, and this is my video presentation for Aviation 322 on fog. So what is fog exactly? It is a surface-based cloud composed of either water droplets or ice crystals. It is most frequently caused by a reduction in surface visibility, which can get below 5 statute miles. It is also one of the most hazardous weather conditions that aviators face today. And also, a small temperature dew point spread is essential for fog to form. Fog can also form very rapidly, resulting in a VFR to low IFR conditions. Fog is prevalent in the coastal areas because there is more of a moisture abundance there, obviously, but it can form anywhere. Seen here. Fog is also really common around industrial areas, and it actually occurs frequently in colder months. However, season and frequency of occurrence varies depending on the location as well. So I'm going to talk about a few of the more common types of fog. As we see here, radiation fog can also be defined as shallow fog. It may be more dense, enough to hide the sky or just conceal part of the sky. And it's also actually known as ground fog, like you kind of see in the bottom picture there. Conditions for radiation fog forms near daybreak or at night. It is restricted to land because water surfaces cool little at nighttime from radiation. So it will typically burn off quickly after sunrise, which we see pretty often here. Advection fog, I like to call this California fog. It's also known as sea fog, and it forms when moist air moves over colder ground or water. And again, this one is more common along the coastal areas. There is a huge source of water there in California. Advection fog deepens as wind speed increases. A pilot will actually observe little difference between advection and radiation fog, except skies may be cloudy above advection fog. And advection fog can move rapidly regardless of time of day. So the next two is upslope fog and steam fog. Upslope fog forms as a result of moist, stable air being cooled adiabatically as it moves up sloping terrain. So that's kind of what you're looking at in this picture here for upslope fog. You can see how the moist air is moving towards the slope. And then as air rises with the terrain, it gradually moves up the slope. So I thought that was a pretty good illustration. So once upslope wind ceases and the fog will actually dissipate, it's common among the Rockies and can extend up to higher altitudes. Steam fog forms when very cold air moves across relatively warm water, so that enough moisture may evaporate from the water surface to produce saturation. As rising water vapor meets the colder air, it immediately recondenses and rises with the air that's being worked from below. So steam fog is associated with shallow layers of unstable air. And I just thought these photos here really exemplified what exactly steam fog, advection fog, radiation, and upslope looks like. So, and then my sources, I actually have the Aviation Weather and Weather Services guide that Glide put out, and then I also reference the Aviation Weather Handbook. That's my presentation. Thank you.